Right, a very good evening to you all. Thank you. Well, good evening, good morning, or good afternoon, depending on where you are in the world. Thank you very much for joining the session. Delighted to be invited to speak here. And yeah, today we're going to be covering two of the most exciting areas of the data world, the ever-evolving machine learning world and the Power BI world that also moves on at a hell of a pace. And looking at how these worlds collide and what happens when you start looking into machine learning with Power BI. As Mark said, my name's Alex Whittles. I'm based near Birmingham in the UK. All my contact details are on the screen. I'm more than happy to take any follow-up with anything afterwards via email, Twitter, etc. Please don't hesitate to drop me an email. So a little bit about me before we start. I'm on the organising committee of SQL Bits. I'm a data platform MVP. Have been for 6 years now. And yeah, my consultancy, Purple Frog, we cover all aspects of Microsoft Data Platform, Power BI, machine learning, data factory, cubes, etc. Anything data analytics is what we do. And also a relatively new venture for the last year and a half is our new software as a service platform, Power BI Sentinel, which if you're using Power BI in your business estate, it's a one-stop shop taking care of automated backups, automated change tracking, usage analysis, documentation, risk report, enhanced lineage that gives you lineage down to table and view level, etc. It sits alongside your Power BI estate, giving you far more control and management than you do otherwise. And when I'm not doing that, I'm also a qualified pilot and was lucky enough to even fly a Spitfire a couple of years ago. So you'll find me up at 5,000 feet whenever I'm not working. But you're not here to listen about that. You're here to listen about machine learning in Power BI. Be pleased to know this is pretty much the last slide we'll be looking at over the next hour and a half. It is an entirely demo-based session. Please do bear with me. Both machine learning and Power BI are ever-evolving tools, and they change on a daily or weekly basis. I know one demo that is definitely not going to work today, but I have a workaround that I can show you because there's a new problem in the Power BI desktop tool. All the rest of them should work, but do bear with me if the demo gods are not shining down on us today. So we're going to be looking at a number of different ways that these two worlds interact. From internal Power BI visuals, what kind of custom visuals are available, how they look. Looking at Azure Cognitive Services, how you can use off-the-shelf pre-built machine learning tools and integrate those into Power BI. Also data flows. If you've got Power BI Premium, then data flows have a really powerful automated ML feature that's very simple to use. And then we'll look at building your own kind of tools, such as Azure ML Studio. If you build your own machine learning model in Azure, how you actually consume that within Power BI, and also looking at how you integrate Python as well. So there's quite a lot to get through. I will be rushing through the demos at a relative pace. As Mark said, if you have any questions, then please do put them down in the question window, and we'll get to those and revisit things towards the end. Right, so let's start out with our test data set. I've got two data sets here, and I've got one which is a table of vehicle data, MPG. And so this is the miles per gallon of a number of vehicles. And we'll see later on in the session where that comes from. But this is basically a list of vehicles along with some information such as the miles per gallon and attributes or features about those vehicles, the number of cylinders, the displacement, size of the engine, the horsepower, weight, acceleration, year, etc., country code. And we'll be using this to try and predict what the MPG is, what the actual fuel efficiency is of these vehicles for new vehicles that come out that we may want to use to try and predict. We've also got some a small data set of tweets where we just have some fake tweets, and we've got the username and a date, and we'll be doing some textual analysis, some semantic analysis over our tweet data. So everything you see at this session is based on these two different data sets. So let's start out with what's built into Power BI Desktop in the visuals that are available to you. Well, if we look on the right here, we have these visuals on in the toolbox. And these are relatively new. I say relatively new. They've been around for 6-12 months now, and they're improving all the time. There's a lot of work going on to enhance these. We have the key influences visual. We have the decomposition tree, and we have Q&A. So let's start out by dropping the key influencers visual. Now, what this does is we give this a data set, we give it a number of columns or attributes or features, and we give it a target, and we say, go off and identify the relationship between these different things, and tell me which of my the fields that I'm bringing in have the most influence over the result. So we're going to predict the MPG, or analyze the MPG, and we're going to feed in all of the other fields here that we're going to. We're not going to include model because that's the textual name of the vehicle. We're not doing text analysis at this stage. So I'm going to run all of those. And in the background, this is building a real-time, relatively simple machine learning algorithm over this data. Now, that's not firing it off to, that's not building a traditional prediction model, etc. All that's doing is running some statistical analysis over the attributes and identifying which are the most relevant. What is statistical analysis? It's now the old word for what we now call machine learning in a simplified world. So we want to figure out what features of a car make it bad for fuel efficiency. So what causes the MPG to decrease? And it goes through and figures out that both the acceleration and the country code of 1, being the USA, are the most important features that actually that give a high likelihood of a poorly performing car from a fuel efficiency perspective. The next one down is the weight. The lighter the car, obviously, the more fuel efficient it is. The year has a reasonable impact. And actually, these bottom three, the horsepower, the size of the engine, and the number of cylinders, don't have as much impact. Now we can click on some of these and see the correlation between them. So this draws us the actual weight on the x-axis and the MPG on the y, and we can clearly see there's a correlation between the two. So it allows you to actually see these correlations very easily, feature by feature. We can also look on the top here at the top segments, and that gives us a clustering algorithm. And in this case, it identified 4 different clusters of vehicles that all share similar features. They share similar, whether it be a combination of size, engine, performance, etc. And these are individual clusters that can be grouped together. So this may be, you could do this over customer behavior to identify different types of customer that you may want to have a different marketing strategy for. But in this case, it's vehicles. So we can look at vehicle segment 1, which has the lowest MPG. So what features make up that segment? Well, the cylinders are more than 5, horsepower is greater than 139, and the year is less than 74. So we can use those features to have a pretty easy way of looking at another vehicle and saying, yep, that's going to fall into category 1 or 2 or 3, etc. So these visuals are improving all the time. It wasn't too long ago when this visual only worked on categorical values, such as is the MPG high or low? It's a Boolean value, true, false, yes, no, high, low. There was an update a few months ago that enabled this for numerical variables. So now we can actually use the numeric MPG value. And the team at Microsoft are working very hard to actually enhance this even further. So there is another one, which is the decomposition tree, and that is basically an enhancement of the key influences. What that does is if we say, let's look at the MPG, we want to analyze the MPG, and we want to explain this by acceleration, by country, by cylinders, etc. Bring them all on. And horsepower, weight and year. And this allows us to say the average MPG across all of our vehicles is 23.5. Well, we can expand that, and we can either choose to break it down by country code, for example. And this then gives us the average MPG per country. Or we can say, well, I don't know what I want to break it down by. Let's break it down by whatever gives us the lowest value of MPG. And it uses the key influencers to decide, actually, it's the horsepower, which is a really good way of breaking this data down. Or we can then expand that by high value, and it gives us the acceleration. So it uses the key influencers to help you navigate through your data. And the point of this is that a Power BI user shouldn't have to know that they're using machine learning tools. It's now becoming democratized to a point where you don't need a data scientist to do some basic, simple ML. it's available in a drag and drop, draggy droppy clicky interface that anyone can use without even realizing that they're using any machine learning. The next side of this is Q&A. So most people who have played with Power BI have played with Q&A over the years. And this is a way of free-form writing a query without having to actually know any SQL, DAX, etc. So we can give it some free text. So over our vehicles, I want to say, what is the best car? Now, it's given me two red underlines here because it doesn't understand what a car means. It doesn't understand what best means. So we have to give it a helping hand here, and we have to define what these terms mean. Now, if we look at the data set, the car is model. It's the model name of the vehicle. So first of all, we want to define car. Car refers to the model. Once we do that, it then understands which data set it's looking at. Is it MPG or is it tweets? And we can say the best MPG is MPG that has a high MPG value. So we're just giving it some information about what a car means, what a good or bad best MPG refers to. And when we do that, we can then ask it what is the best car, and that didn't work. Let's try it again. So MPG that have a high MPG, that's not working. Okay, welcome to the demo gods. Let's try. It likes low MPG for some reason. Let's go with that. So it now knows that that is the best car. Actually, it's the worst car, but you get the point. So we can go through and define these different meanings behind our data so that a user can come in here and ask it a question. Now, what's that doing? Well, that's taking that sentence, that question, and doing semantic analysis over it to try and determine what the meaning of that question is. Can it relate that to things it knows about, such as fields in the data set, such as values it already has? If it doesn't, it can look at the information we've given it, and actually we can look at the cog here to go on to manage terms, and we can see all the definitions and the terms we've given it. So it'll look through those and try and work out what that sentence actually means. And it'll turn that into a data set, or it'll turn it into a chart or a table, etc. There are, however, some problems with this. As we saw, it liked the low MPG, it didn't like high MPG. An hour ago in my test, worked fine. So there are some challenges with that. And the level of understanding of these questions can be a little flaky. I don't yet expose this to any actual live customers. We show them it, we talk them through it, but we recommend they don't roll it out around the organization because it tends to be more frustrating than good at the moment. But it is improving all the time, and it won't be long before it's a very powerful system. Another problem you have to watch out for with this is we've already defined best. So if we say, what is my best tweet? Well, it doesn't understand because it knows tweet is from the tweets data set because there's a column there called tweet. But the MPG, we've already defined best as meaning the best MPG, which comes from a different data set, and there's no relationship between these two. And so it doesn't understand that, and we have a problem. If we go in and delete these terms, we can then redefine that, and it now doesn't understand. So it knows we're looking at tweets because it's brought out all of our tweets, but it doesn't understand what best means. So we can now go and redefine best to be relevant to our Twitter data set. So if you're going to use this over a Power BI data set, make sure that you don't have conflicting data in there. You want the data set to be relatively small so that you can define what these terms mean, and so there's no ambiguity or confusion around them. But if we want to define here what's the best tweet, we can't actually do that because all we have is a tweet ID, just an incrementing number. We have the date. There's nothing in there that we can use to determine is it good or bad. We could put a function there to say is it the longest or the shortest or the most recent, but that doesn't tell us is it good or not. To do that, we need to do some semantic analysis over that data. So how can we do that? Well, if we go back to our table here and we go to Power Query, we have some AI functions, some ML functions that we can apply directly in Power Query that will help us do that. So if I choose our tweet data set, and up at the top, we have a few AI insights options, and this is where we interact with our machine learning tools. The first one of which, and probably the easiest, is the text analysis. So what happens if we click on that? We're already logged into Power BI, and so it knows our Power BI tenant. We know the Power BI account it's logged in with. And we can see down the bottom here, premium capacity used for AI insights. To use these tools, you have to have a premium capacity in your Power BI. You cannot do it using this method with Power BI Pro. So you choose the premium capacity that you want to be used for this machine learning workload. You'll notice here, actually, I'm using a Power BI embedded service instead. And you can do that. Power BI Embedded does actually give you the same functionality as Power BI Premium at a much lower cost. So if you want to play with this, when you go and spin up your Power BI Embedded, which you create using the Azure portal, by the way, I've got a Power BI Embedded service resource down here. So you create this through your Azure portal. It does ask you what size you want it, and you can give it from A1 to A6. Do note when you do this that the A1 level does not support any machine learning functionality. You have to have minimum of A2. So any of these are going to work. But as soon as you get an A2, then you can use machine learning functionality in Power BI. The beauty about the embedded SKU is that you have this wonderful pause button. You can turn it on when you want it and turn it off when you don't want it. So if you want to play around with this, you haven't got to spend $5,000 a month on a premium capacity. Create an embedded, create it as an A2, turn it on, use it, turn it off. Much, much cheaper way of playing around with this. So what happens if we do that? As soon as we choose a capacity, a premium capacity, we now get these three functions: detect language, extract key phrases, and score sentiment. We're going to use the score sentiment, and that will look at a particular text field. Here we're going to choose the tweet, and we can give it a language if we want to. Now, if you don't, it'll automatically detect the language. All that does is it runs this detect language first and automatically pipes the result into the sentiment function. We're not going to bother with that because all of these are in a single language. That's right. Let's go back to Power BI. So that's now reloading this or rerunning this Power Query, and it gives us an extra column. And that column gives us a score between 0 and 1. 0 being it's bad, it's a negative sentiment, and 1 being it's brilliant, it's perfect. 0.5 means it's in the middle, it doesn't know, it's ambiguous. Do note that it doesn't allocate this as a number properly. So whenever you do pretty much any machine learning work, you have to transfer the data type to a decimal in order to be able to analyze the data properly afterwards. So once you've got this, you can then rank this, you can chart it, you can filter it, etc. But let's go back to our Power BI visuals, and we can see what impact that has on our Q&A panel. Worth noting, we use these tools in SQL bits, both the semantic analysis and also the key phrase extraction. We get in the region of something like 10 to 20,000 feedback forms after every conference. And it's really important to, we need to look at all of them, but we need to prioritize those we look at. And we want to prioritize those that are on the negative side, and then of those, extract the key phrases. So we don't want to look at 500 different messages. We want to extract the meaning behind those 500 messages so we can group them and then prioritize those. Very, very useful for doing that. So now we've got our sentiment, we can then define what best means. And we want best to be the high score sentiment. That'll run a quick test. It validates it, and we can save it. So now it's now able to detect our best tweet with a score of 0.98. So with very little work and with just spinning up a Power BI embedded SKU, we've actually done some quite interesting work there purely in the Power BI portal. Okay. So what happens if you don't have a Power BI Premium or an embedded capacity to use? Can you still use these features? And yes, you can. I'm just going to erase that work we've just done and then redo it using a different method. So you'll notice when we added the apply score sentiment, if we look at the advanced editor for that, all that's doing is calling a function, AI functions post-process, and it does the Cognitive Services score sentiment text function. If we get rid of that, and obviously it's very easy to plug that in, it's very simple, you haven't got to do anything. And that score sentiment function actually creates, you can see it here, there's a function it creates in Power Query. We're going to delete that function and we're going to create it ourselves. So if we go back to the Azure portal, we can create a new resource called Cognitive Services. Now, Cognitive Services is a batch of pre-built functions that you can use just using an API. You can use through code, C#, or through tools like Power BI. I'm not going to create one of these because I've already got one. But the critical thing we need to look at is if we go to my existing cognitive service, there we go, is that we have the pricing tier of this starts out being free. For up to 5,000 transactions per 30 days, you can play with this for zero cost. This is what we use actually for the SQL bits semantic analysis. When we want to do some analysis, we scale it up, run the analysis, and then scale it back down again. So you're not paying all the time for the service. The key thing here is the keys and endpoints. This gives you the key to use in the API. Once you've got that, you can then go into Power BI and fire off a command that will interface with these cognitive services. So I'm going to go back into Power BI. Yep, that's the one. I'm going to go into my tweets and I'm going to copy and paste because I don't like writing complex code in a demo. I'm going to choose new source and put a blank query in. And this blank query, if I go to the advanced editor, I'm just going to paste in this M function. Now that is the function that interfaces with the Cognitive Services API. This is the API key that I just got from the portal. That's obviously the key to my demo tenant. Please don't use that. I will change that. And then it just passes through whatever text gets passed through as the parameter of the function, and then passes it off to the Azure Cognitive Services and gets a response and passes back the response there, which is the score. So if we do that, that just creates a function here called query1. Let's rename that to sentiment. And now we've got that sentiment function that accepts text as a parameter. We can go back to our tweets. We can go to transform, and we have, no, it's not transform, it's add column. And we have this invoke custom function. When we click on that, we can say, I want to call my sentiment function. I'm going to call this sentiment, and I'm going to pass through my text column of tweet. That's what I want to use as the input to my machine learning function. I do that, and straight away it comes back with the sentiment score. And I can then, as usual, change it to a decimal, and you've now got machine learning sentiment analysis with zero cost, up to whatever level I said it was available, up to 5,000 calls per month, which is pretty good for a testing system. Right, let's go back to something a little more basic again. Before, when we were looking at let's just put that back into our visuals. There we go. Wait for that to reload that data set. We were looking at the built-in visuals. One thing I didn't show you was the third-party visuals. What else is available to save you having to interact with your own, with cognitive services, etc. And there are some quite nice ones there. I'm not going to go through many of them. I'm just going to show you one just to show the kind of concept of what they can do. So we're going to look for, we've got an advanced analytics section here. And in there's quite a lot of visuals that wrap up a lot of work for you. I'm going to search for clustering. There's one in particular, this clustering using optics, which is quite a nice visual to play with. So we're going to drop that onto the canvas. We have to enable scripts for it to run. And we're going to use the same data set, the MPG, and we're going to use the MPG on the x-axis. Change that to don't summarize. And then we're going to use a function of displacement and weight on the x-axis, on the y-axis. And this is now going to run a model and create a chart similar to you saw before in the key influencers explainer. But this does some quite nice stuff. So what this is doing is saying, right, all of my vehicles fit into this one grouped cluster. There's quite a nice correlation between those features. And obviously you can see the line of best fit there. You can see that they all wrap up into one group. Quite often with data, you'll see they fit into 2 groups or 3 groups or 4 groups. What we've got here is on the right-hand side, we've got this this data point over on the right, which clearly sits outside of the normal structure we see for the rest of the data. Now hover over that and we don't really get any useful information. So I'm just going to drag the vehicle model on as the tooltip, and then we'll be able to see which model it is that's causing a problem. Now there could be a couple of reasons why this data point is out there. So it's a Mazda GLC. There's 2 reasons why that data point could be out there. One is that it is genuine data. Someone put in an electric vehicle, for example, in a gas-powered data set. Or more likely in this case is it's dirty data. Now, 2 things you may want to do with that. One is identify that vehicle, go and understand why it's there. It shouldn't be, you shouldn't have dirty data in your data set. So either clean it, fix it, find out what the value should be and correct it at source. Or if you can't correct it at source, delete it. And the reason for deleting it is that when we're using this data to train a prediction model, we don't want these outliers, these exceptions, these data errors to influence the quality of the model that we create. So it's very important to use tools like this to explore different relationships between the factors and the features to understand whether you do have outliers and use it to prepare your data and clean. You don't obviously have to use this to prepare for machine learning work. You can do it just to analyze your data and understand problems just in your normal reporting. But tools like this clustering give you quite a powerful way of being able to see that. Okay. So we've looked so far at the simple side of ML, pre-built models, cognitive services that are just there for you. Even when you've got Power BI Premium, you can just click on a button and it does the work for you. But what if you want to do something a little more custom? What if you want to write your own or create your own machine learning model that does something more than what we've seen here? Let's say we actually want to not just analyze the MPG, but we want to build a prediction model over it. We've got a new vehicle that's coming out. We know what the size of the engine, the weight, displacement, etc. is going to be. What is the predicted MPG going to be? So let's build something a little more fun. So let's go back into our Azure portal. And if we create a new resource, we can create one called Machine Learning Studio. So we want the Machine Learning Studio Classic workspace for this. And this just spins up a machine learning environment for us. We give it the usual things, the subscription resource group, location, etc. I already have one, so I'm not going to create another one. Let's go into the one I've already got. Machine Learning Workspace. And from here, we can just now launch our launch our interface. So this is a very nice, easy way of playing around with building your own machine learning model without having to know too much about the mathematics and code behind it, because it's a codeless environment. Think of it as integration services for machine learning. We've got a few experiments I've already created. I'm going to use the button on the bottom left to create a new experiment. And it gives you loads of sample experiments that you can play with and have a look at. We're going to create a blank experiment here. We're going to do complete coding from scratch. We like to give ourselves a hard time over the demos. Now you can upload your own data by using that button there with data, but actually there's a whole load of data, sample data sets built in here that you can use. So if we expand our saved data sets, we can see there's census information, there's Bill's RGB image, blood donation data, cancer information, flight delays, etc. The one we want is this MPG data for various automobiles, which is where I got the data from in the earlier demos. We can right click on here and visualize, and we can see what the content of the data is. You should recognize it. Now, within this prediction model, we're going to use all of these columns to try and predict our MPG column. What we're not going to use is the model, the actual text analysis, the text field. So we actually want to remove that from the data set to prevent it from getting in the way. So we can use all the different tools on the left, or we can search for them because the menu is quite big. And so we want to use a select columns in dataset, drag it on, hook the two together, and we can then launch the column selector on the right hand side, and we can choose all of the columns that we want to include in our model. Okay, let's just, there we go. So if we're going to build our machine learning model, there's a couple of steps we need to go through. The first thing is this data that we have up at the top. This is historic data that we already know. It's vehicles that we already know the MPG of. This is our training set. We need to feed this into our model so it can learn the pattern and the relationships. We also want to keep some of our data to one side to act as a test, so we can test the model afterwards to see how good a predictor it is. So we want to split our data into two. Let's go to split. And we can feed in that data, and over on the right hand side we can give it the fraction of rows we want to keep. So I'm going to choose 0.8, 80%, and so we're going to get 80% of our rows coming out of that output and 20% coming out of that output. So with that, we want to train our model. So let's go to train, and we can pass to our 80% of training data into our train function. Now we need to tell it which algorithm we want to use. And this is the only tricky part of this whole process, is how do you know which algorithm to choose? Is it a neural network, a decision tree? There's so many to choose from. And you do need to have a little bit of knowledge on understanding which one's which. Now I know that this MPG value is a number. Therefore, a regression model is likely to be a good option for this. So I can just search for regression, and we see a load of different regression algorithms that we can use. I'm going to go for Bayesian linear regression, only because I know that that's quite appropriate for this data set. You learn these over time. You can experiment with them to play around with them to get better acquainted. So within our trained model, we need to tell it that we actually want to predict the MPG column. So on our launch column selector on the right, we have to load that and say, I want to predict the MPG column. Okay, and now we need to determine how good a prediction model this has created, and we do that by scoring it. You think of this as an end-of-year exam for a kid at school. We take all the model that we've built up, we give it the testing data, and then this score will run those 20% of cases we kept back. We obviously know the MPG of those, but it's hidden from the model. We ask the model to predict the MPG for those, and we compare that against the value we know is correct, and we see how good it is at predicting it. And we can give that a run. And so what's happening now is it's taking that data set, it's splitting it in two, it's training our model, and then scoring it. And all of those are ticked, so we're good. What we could do, if we had time, is add an evaluate option here, feed that in, and evaluate has two different inputs. So we could create a whole nother model here and then use this to compare the results so you can see how good different models work. But we haven't got time to go into that for now. So I'm happy with this model. This is all green. We can assume this is going to be a reasonably good predictor of our MPG. And so I'm going to use this button on the bottom called Setup Web Service. And we're going to use a predictive web service. Let's try it. There we go. So this is now going to simplify our screen. And when we had the original input, it had the vehicle's name, the model. And so we needed this select columns to remove it. Well, with our web service, we don't need that. We're not going to give it the model name. So we can skip that step and just plug the web service input directly into the scoring. And so we'll get our experiment, our actual machine learning algorithm we've trained. We're going to give it an input through our web service, and it'll score it and give us an output prediction. So we're going to run that just to make sure everything's all hooked in correctly. And we get, hopefully, all greens. There we go. And so now I can deploy a web service to my Azure portal. And this is now compiling that whole, or I will do once I click deploy. Let's give it a name. So let's call this and so that's the name we're going to give our web service. We need to choose which machine learning classic workspace we're going to embed this in. You don't need to create a classic workspace to play with a machine learning model. You can just do it directly in this portal, but you can't compile this and deploy it and use it until you create this machine learning classic workspace in your Azure portal, which is why I've already created one. So I'm going to choose that, and this is the workspace that this model is going to be compiled and deployed to. So that's now compiling our model, and let's try it again without any spaces in the name. That's better. Now, what this is going to do is it's going to create essentially our own cognitive service. The thing we used earlier where we just hooked in Power BI straight into that service, this is now our own, but it's our own prediction model. Now, we can interface with this using C# code, in a website, in Power BI, it doesn't really matter. But it also builds us a test web service. We haven't even got to write our own web service code to be able to use this. We can just say we don't want MPG because we're predicting that. Let's try something. Let's go for 8 cylinders, 200 cubic inches, 200 horsepower, weight is 2,000 pounds, acceleration is 0 to 60 in 10 seconds, year 1970, country code 1. So we're now going to, this is a test interface as if we'd created our own website. We're going to give it this data and just run a test and see what it comes out with. So it took a while to build and to learn, to train our model, but that was an instant response when we come to query it. So giving it this data, it's given us a score of 20.8 MPG. Let's change some of these numbers. Let's make it a 1990 and see if that changes. Yeah, it's now 32. So we can see just by changing the year, it's given us a completely different prediction of that data. Let's make it 3,000 pounds, and it's now down to 26. So you can play with these numbers, and every time you click test, it sends off an API call to the Azure service we've just created with the key, sends the data in a JSON block, gets the results back, and displays it on the screen. Now, if you want to write this code, if we go back to web services, we can use, there's some information here, I can't remember where it is, where it actually gives you, there we go, it actually gives you the C# code that you can embed into your application that you can use to call that, that machine learning algorithm. This isn't the code of the machine learning model, it's the code of how to interface with it. But this session is about Power BI, not writing C#. So we don't want to write Python or C#. We can just go straight into Power BI. Now, what we're going to do with this is go back to our data set. We're going to go to our MPG data and go to transform. And I will give you a heads up, this is the demo that is going to fail. I can tell you that now, but I will show you I'll show you working in a different way later on. So what we should be able to do here is click on this Azure Machine Learning box on the top. And when we do that, it should connect up to our Azure account, the one we're connected to, and give us a list of all of the different machine learning models that we've created and that are available in our Azure ML Classic workspace. And this is the one that's been giving an error because whatever populates this screen is not working at the moment, or at least it wasn't earlier. I am hoping it will have fixed itself. Cross your fingers. No. So what should happen is it should give you a list of all of the experiments or all of the models that you've deployed to your Classic workspace, and you can click on it and then map it to the input columns that already exist in the data set up here in your MPG, and then it will then output a column as the predicted MPG value. It ends up looking very similar to the text analysis we saw earlier, where it just plugs into a function and just calls it for you. But that's not going to work. But you end up with the same results, but it uses a slightly different backend, and it gives you more control over creating that that machine learning model, because you get control of how you define the algorithm, the parameters, the setup, and everything else. Right, so let's now look at a completely different way of being able to write your own code. We're getting a little more into the coding now, and that's by writing some Python code. And Power BI has built-in integration with both R and Python. I would probably recommend Python as the better starting point, but if you've got existing R skills, then use R. So we're going to go back to our sentiment analysis now and try and analyze our tweet. So I'm going to delete the steps we've already created, our invoking custom functions. We're going to delete this function here and restart again from scratch. Okay. So what we're going to do now is we're going to transform our data, and we've got these run R script or run Python script on the right-hand side of the transform ribbon. And this allows us to write a complete script of R or Python that will act as a step in our Power Query code. So I'm going to run a Python script, and any data that comes out of the previous step of Power Query, which is essentially this data set, can be accessed in Python using the dataset variable, which is just a pandas data frame. Again, I'm not going to write custom code in a demo, so here's one I made earlier. There we go. So this code, we're importing pandas, which is the data frame called dataset, so we can interact with this. We're importing this NLTK sentiment Vader library, which has a sentiment analyzer function inside it. And we're going to, so we're using from our data set, we're creating a new column called sentiment based on the tweet column of our data set. And we're applying a lambda function, which is the sentiment polarity scores to it. Now, I'm not a Python expert. I copied and pasted that. It's 4 lines. It's not rocket science. To make this work, you do need to have Python installed on your local machine. And you set up Power BI, you can see here, the script will run using the following Python installation. So you have to have Python installed locally on your machine. When you do have that, this can interact with it. And what Power BI does is it passes the data set to this script, uses that library or that Python runtime to execute it, and that returns back into Power Query. And then once you do that, click on OK. It's now running that, and it'll add, we've got to give it some privacy information. Ignore it for the moment. It's going to call that sentiment analysis function in Python over our data set. Now it returns the data as an entire table, so we can just drill through into the table and see the results, hopefully. All in good time. There we go. So that's now given us a very similar data set that we had before with the cognitive service sentiment analysis, with the difference that this includes negative numbers. So this particular Python library does a -1 to +1, so that's the range, and 0 is the unknown sitting on the fence. Apart from that, it's exactly the same. It has a bit of a problem with dates, so I'm just going to remove those for now just to keep it simple. But now we've got a full sentiment analysis without using any Azure functionality at all. It's entirely local. The one thing you have to watch out for with this is when you deploy this to powerbi.com, powerbi.com does not have a Python runtime available. Therefore, you have to be running the personal gateway, the Power BI personal gateway, and set up this Power BI dataset to use that personal gateway. And that personal gateway has to be running on a machine with the Python runtime installed. So my local laptop, for example. And what happens then is when Power BI wants to run this Power Query, it gets the data, passes it down through the gateway to my local PC, runs the Python, and sends the results back again. So that's fine for small data sets. Is not fine for very large data sets. So do bear that in mind when you're looking at the scalability of this. You do want to be using the Azure functionality for machine learning to scale this up. Also note that it has to be the personal gateway. It will not work on the enterprise gateway. So a couple of things to watch out for if you want to do this. But it does give you quite a lot of flexibility in writing your own Python functionality, embedding it directly inside Power BI. I will also say that there's two ways you can embed Python into Power BI. One is, as we've seen, as a step in Power Query. And actually, what I will show you before I skip off that, once that loads, is how to get back to that script, because that catches a few people out. If we go back to transform data, we can see in the tweets that we have a step called run Python script on the right. Just click on the cog to the right of it, and that then just brings up the Python script again. And that's the way to get back to that script to make changes and edit it. But apart from that, that's all just one step in the whole Power Query process. Okay, you do also have, if you go to the visuals, there we go, an R and a Python visual over on in the visuals pane. So you can use this in exactly the same way to interface with a pandas data frame called datasets, create a visual using the vast wealth of libraries that exist in R and Python, R especially, to create some really nice visuals that don't exist in the built-in visuals or custom visuals space. Okay. Right. Next thing we're going to be looking at is moving to the Power BI portal. I think that's our next step. So here I've got a Power BI premium workspace called Machine Learning Demo. We know it's premium because we've got the little diamond there. This actually is the same Power BI embedded capacity that I was using earlier. This works on embedded the same way as Power BI Premium. So data flows are one of the new-ish features of Power BI, PowerBI.com. And a data flow is essentially a copy of a Power Query function. So if you write Power Query in a Power BI desktop dataset, you can copy and paste that Power Query code into a data flow, and it will exist as a single table up in your workspace. It's actually a collection of these tables, so each data flow can have many entities. Each entity is one table, but you can use those to go and grab data from wherever you want. As well as that, so we can use that to standardize our Power Query code. If we want to import data from our CRM system and we have 20 different Power BI reports, we don't want all 20 Power BI reports running the same Power Query code against our CRM system. So we can do it once, bring the data out into a data flow, and then all of our Power BI reports can consume that same data flow. So it's a way of standardizing logic and simplifying. But the other key functionality they have is built-in machine learning. So let's create a new data flow. Now, a lot of this stuff takes quite a long time to run, so I'm going to do a lot of jumping to one I've made earlier, so do bear that in mind. I'm not going to run through the entire demo, or we'll be here for 2 hours. I'm going to add a new entity, and this gives us Power Query. Power Query in the browser, in exactly the same as you have in Power BI Desktop. I'm going to start with a blank query and pull data out of an Azure SQL DB that I already have available. This is our MPG data, again, exactly the same as we were using earlier. And we're going to call this, let's give it some authentication. And if the demigods are smiling, we get our data. I'm going to call this MPG training. There we go. So I'm just going to get rid of this column high MPG, low MPG, because that's a Boolean that we don't want including in our prediction model. And I'm going to save and close that. So that creates an entity, a table called MPG training. And I'm going to call this MPG pass hybrid 2020-08-04. So within this data flow, we can define many different entities, many different tables, each containing a different Power Query to go and pull data from wherever we want. And this just contains these columns in this data set. What we can do, though, is use this little brain icon on the right to run a machine learning model over the top of this and use this data to create a prediction model. So let's go and do this. Add a machine learning model. And we want to use this MPG training entity. We've only got one table in there, so there's only one there. What is our outcome? Which is the column we want to try and predict? We want to predict the MPG. It now does some analysis over that field and tries to help us by giving us some advice on the kind of model that we should be using for this. It recognizes that it's a numerical value, and so a regression model is appropriate for it. So let's accept the recommendation and go next. Now, one of the differences between, actually, I'll go back to that. So now it says which columns do we want to use, which features do we want to use to include in this prediction model. Now, it does the same key influencers work we saw earlier. It does on the fly here, and it actually looks at the relative impact of each of these columns to determine whether they should be included or not. And it says that acceleration actually has quite a low correlation. So do you want to include it or not? I'm going to ignore its recommendations and include it anyway. And we're going to call this MPG pass hybrid predictor. And this isn't just creating a model. This is auto ML or automated ML. If you remember back in the ML classic workspace, we had to go and choose a Bayesian linear regression model. With this, we don't. We just say, here's our data. You go and figure out which algorithm is going to work best on our data. What it will do is it'll actually go and generate dozens or hundreds of algorithms behind the scenes. It'll compare the results of all of them, choose the best one, and say, here you go, there's your result. So it does all of the hard work for you. It creates all the different models and works out which one is going to be the most appropriate to give you the best prediction. To do that takes a lot of time. So we've got a slider here where we can say, well, how much time do we want to give it? Up to 360 minutes or down to 5. We're going to go 5, and even then, we're not going to sit there and wait for it. But I'm going to click Save and Train, and straight away we can see it's got the. If we go back into this this data flow, we can see straight away it's taken our input data flow and created 2 others from it. And this is our training and testing data set exactly the same as we did in the ML Classic workspace. We did a manual split into two. This has just done it automatically. So it's going to use the training data flow to create the model, and then, or create lots of models. It'll pass the testing data through every single model and compare the model's prediction against the MPG that it already knows and determine which is the most optimal model. If we go back to our workspace, we can see that that is going to be spinning away for quite some time. And we haven't got time to wait for that. So we're going to skip to one I made earlier. And now we have not only our entities, but we also have a machine learning model. And what I'm going to do now is upload a new entity. So that was all of our training information. What I'm going to do now is hook this into our live production set of new vehicles that we don't know the MPG of. Now, it's actually the same data set for demo purposes, but you get the point. I'm going to do a little bit of Power Query preparation on this when it lets me. Let's get rid of the MPG. I'm going to get rid of this MPG column because I actually want to predict this. I don't want to have it as part of the input data set. So normally this would be our production data set coming in, and we want our ML to add an extra column of what that MPG is going to be. So we're going to call this live data. Okay. Now, what I will show you actually is this AI Insights button up at the top. Now, if we click on that, this gives us all sorts of different ML models that we can run over this data. So it takes a while to populate the list. We have the cognitive services that we saw earlier, the score sentiment, we have the detect language, key phrases, image tagging, etc. We also have our Power BI machine learning models. So these are the prediction models that we've created inside these data flows. We also have the Azure machine learning models. Now this is the model we created earlier with our parse hybrid ML services. So even though we couldn't access that in Power BI desktop, we can access the resulting model in powerbi.com using data flows. So if we choose that, it knows all of the inputs that are required. It actually matches them to the columns that are already in the data set, and we can just click apply. And that will then add an extra step in our Power Query that takes that data, sends it off to our compiled machine learning model that we created in the classic ML Studio workspace, and return the resulting column. Or we can use one of the ones we've built in our the automated ML in our data flow. For now, let's just use the model we created in the data flow to keep it all within data flows, and it does the same thing. All of our inputs are mapped automatically to our fields. Click apply, and we've now got an extra step here where it invokes that machine learning function. And it gives us a nice error. There we go. Demo gods. Normally that would give you the actual the prediction results. Let's instead try it again with the Azure ML model. Try it again. In fact, I can choose one I had earlier. No, it's not playing ball today. Normally that would give you that number on the side, and then you can just get the predicted MPG, 23, whatever it may be, and use it as the output. So what does this data flow? There's a lot of different components in the data flow. How do they all kind of fit together? If we jump back to our slides here, This is really the high-level basic summary of how the data flows fits together. First of all, we took our historical data, the data we know about already with the MPG already in there. We load that into a data flow. It then splits into two, our training and testing data sets. They're both used to create lots of these different machine learning models, and it uses the testing data set to score them all and work out the winner. Once we've got our resulting model, we then hook in our live data feed, plug it into a data flow. It passes it through our machine learning model and gives us an output, actually two data flows, an enhanced and an explanations. The enhanced data flow is an exact copy of the input, but with the extra column predicted on the end, the MPG. If you want to know why it's done that and which of the features were most important and how the internals worked, there's some quite nice information in the explanations data flow, so you can explore it and understand it better. But you can then plug in Power BI directly into your enhanced data set, and every time this gets refreshed, you can then get the output results into Power BI. So what does that look like? If we go to one I made earlier, then I created here we go. So we get a test data flow that I plugged in, plug it into our machine learning model, and we get our enriched and the explanations here. So you can use these three to actually to understand, to get the output and to understand what's happened. So we've then got these computed data flows that daisy chain to create our prediction. How do we consume that in Power BI? All we have to do is go into Power BI, get data, and we have an option here, get data from our data flows. And as long as we're signed into Power BI, it will then look up at powerbi.com. It'll look through all of the workspaces that we have access to, find all of the data flows that are available to us, and give us a list in here. So we've got in our machine learning demo, we've got our data set, our data flow here, and I think it was that one there, the enriched data flow, which was the output. So we can tick on that. We can transform the data if we want to. We can use Power Query, but we can see at the end of our data set, it's given us a prediction column, and this is the prediction that the output of the model. So let's give that a load. And we now have our enriched data set on the right. And we can just go into the table view and have a look at that. And we can see that's our predicted model, predicted value. It does include some explanation in this column, which is a summary of the other data flow. I've actually left the original MPG that we knew about in here, so you could easily just find the difference between those two to work out how good or bad that prediction is. Okay, let's go back to the slides. Right, so data flows are actually a very powerful way of writing models because you don't have to know any code behind them. All you've got to do is prepare your data set, prepare your input. You need to give it a good set of historical data that it can use to train with. If you don't have a good set of clean training data, it's not going to give you a good model. So remember we looked earlier at the clustering to identify outliers. That is really important to identify those and remove them so that when you feed it into your training, it knows they shouldn't be included. The beauty about this is the automated aspect of it. You don't have to understand all the different algorithms and the mathematics behind them to be able to do this. It goes through and creates them all for you, and you can just use the best one that it comes out with. Does this replace the need to have a data scientist? Absolutely not. Any data scientist will tell you that at least 80% of their time is not spent training, testing models. It's spent preparing the underlying data set. If you've got a rubbish underlying historical data set, you're going to get a rubbish model. We're all data people. Spend your time preparing your data. Work out which features, which columns should be fed into the model. I was doing some work for a chain of gyms recently, looking at customer churn. It's no good looking at how many visits someone's had to a gym in the last month. You actually want to know, is that more or less than the previous month? And is that more or less than the previous month? Doing some preparation, some pre-calculations on the data to work out, is that increasing or decreasing? That then becomes a good feature to input into your machine learning model. So think very carefully about what data you're bringing in, and use the time to prepare your data, clean it, to give you a good result. But this takes away the pain of actually having to know how to write all the code to create the model itself. Obviously, this is not a perfect solution by any stretch of imagination. It is still, any automated system is going to be limited in its functionality. So you still absolutely want data scientists to do the more advanced work. What this does is it gives everyone the ability to create medium scale ML without having to be an expert in the functionality. It's democratizing ML to the masses at a certain level. There is still a huge need for the experts to come and do the more complex side of it. Just before we wrap up, I just want to show you that screen. If you do want to start playing around with Python in Power BI, this is basically the code that I used in the demo. You have some preparation to do. So in order to run this code inside Power BI, first of all, you need to install the relevant libraries, pandas, NLTK, matplotlib, etc. And then within Python, we want to import NLTK, download this Veda lexicon library that we're using down here. And once you've done that, you can then just copy and paste that code. So by all means, take a screenshot of that, reuse it if you want to. A couple of things to bear in mind. You can install Python by going to python.org. You do need the personal gateway on a machine with Python installed to be able to use it. And do read up on using pandas data frames, because that's how Power BI passes data in and out of Power BI. Okay, that I think is all we have to go through. So, Mark, do we have any questions in the chat window?
Thank you very much for that, Alex. That was brilliant. Excuse me. Yes, we've got a few questions. If anyone's got any more questions, and also put them in the chat window. So going right back to the beginning of the presentation, you gave a demo on Q&A, and you're defining what exactly best car was. Is it possible to do complex meanings when you're defining terms?
I wish it was. That's one of the challenges. A very, very good question. No, it's not. And that's part of the challenge, is that it is a very, very basic system. Yeah. Defining those terms, to me, is one of the biggest limitations. An hour before I came online, I was quite happily defining best car as highest MPG. In the demo, it didn't work. It's a little bit flaky, and it is very simple. Sometimes it won't let you define what you want.
Yeah.
So no, they are very simple, very basic, and I think that's one of the key limitations. When that terms functionality becomes more complex, it'll become a lot more usable. But at the moment, the only option you've got is to create very small, very focused data sets. There's the age-old debate in the cube world: should you have one big cube in an organization or lots of small cubes? The answer with cubes was usually one big one. That's now exactly the opposite of Power BI. You want lots of small ones. And this is part of the reason, is with lots of small data sets, they can become a lot more focused. And tools like Q&A then have a better chance of working.
Right. Another thing that's just sprung to mind regarding that, is there any, so let's say you've defined lots of descriptions and meanings. Is there a way to actually export them and import them into another model?
It's a very good question. I don't believe there is. Let me just jump back to my demo and we'll have a look. One of the things you do want to do with this, which is kind of related, is there's an option to monitor what's happening with Q&A. Sorry, I don't want to be in there at all. You can log the questions people are asking, and let's get a new page, drop on a Q&A. So again, by going onto the cog on the top right, you can review the questions. And obviously no one's been asking questions on this because I haven't published it. But here it will list all the different questions that people have been asking. So you can monitor what your users are doing and seeing if they're getting any good answers. That is very important, because if you don't monitor that, you're not going to be able to improve the functionality, define these terms, and improve the whole functionality of it. There is a teach Q&A, so you can keep asking the questions here and use that to help define these terms. The list of terms here, which should have given me the list of terms. No, it's giving me an error. Why is that not working now? It's giving me an error on the other screen. Right, this should be the list of terms that are used. As far as I'm aware, there's no export option here to actually export them. Whether there is on the portal or not, I don't know. As I say, I'm very reluctant to use Q&A out in production, because I tend to find it actually decreases people's confidence in the system, because they try it and it doesn't work and they get frustrated and they just stop trying to use it. And so if we did try and expose it, I don't think it would have a very long life. So I'm specifically holding off until it reaches a point of maturity where I have some confidence that most people are going to be able to benefit from it. And at that point, I think we'll start pushing it out there.
So, I mean, Q&A was one of these big hot things, wasn't it, a few years ago? Is the product team still actively working on it, or do you think
Absolutely. Yeah. If you look at the investment in where Microsoft are putting the work in Power BI, a huge amount of it is going into machine learning, and that is Q&A. It's also the key influencers. It's the decomp tree, and there's a lot more coming as well. I can't give you details, but there's a lot of work being done. There's a load more visuals, or some really nice visuals, that are going to come out that will really add an extra level of functionality and power to Power BI. And again, the point is they're going to be simplified, and so simple that you won't really know you're using ML. It's all hidden behind the scenes. It's simplifying and democratizing the functionality, so most people using it won't even know they're using it. It's just a visual to them. And there's a lot more work being done on that, and Q&A as well. It's ever evolving.
Great stuff. Okay, so one of your earlier examples, you used a custom visual. Recently, Martin Schoenby wrote a blog post about his experiences supporting custom visuals and problems with it, and the functionality and support from the supplier. Do you have any similar reservations of using custom visuals? And if so, how do you decide on which ones to use?
There speaks someone with experience. Absolutely, yes, you are absolutely right. I make a point of not using custom visuals in important Power BI reports. We have one of our customers who we do all the BI work for them, and then they white label it as their product. They decided to use one custom visual in every single Power BI report they sent out to a lot of customers, including some very large American government organizations, etc. And one day there was a PowerBI.com update to the service. Turns out the visual had been written by some bloke in his bedroom, and he got bored of it and had stopped updating it. And yeah, there was no support. There was no way of getting it fixed. They had to very quickly rewrite all of their dashboards, and they had about 20 to 30 pages on each Power BI report. Every single page was using this visual about 4 or 5 times. Wow. It was quite a major bit of work to rewrite, and obviously all of their customers' dashboards stopped working overnight. I have a concern over that model of, do you get proper support? So with the custom visual that I showed earlier, the clustering, I use those a lot of custom visuals when I'm doing power user exploratory work, using Power BI to explore data, to play with it, to understand it, to profile it. But that's me using Power BI Desktop, or my team using Power BI Desktop, rather than publishing that as a published production report out to the board of directors, for example. So there's a difference there. If you're using it personally, who cares if it breaks? You can very easily change to a different visual with no business downtime. If you are publishing it as a business critical dashboard, think very carefully about custom visuals, explore the author, where they've come from, are they certified, is there support, etc. But yeah, you're right to have that concern.
Okay, great. So we had a comment from Venkat, who you were given a demo on ML Studio Classic, and he made a comment, so I'd just like you to confirm whether it's true or not, that ML Studio Classic is deprecated and replaced by ML Studio. I think there he means Azure Machine Learning. Is this true, and could you explain the difference between them?
Absolutely, yes. There is some confusion at the moment around how the two sit side by side. ML Studio Classic I have not heard that it is being deprecated, but I could be wrong on that. It is certainly a more simplified version, more simplified tool set than the full ML Studio. The reason I use that is it's far quicker and more drag and drop to do a demo. There's no way you could do a demo like that quickly from scratch in the full ML Studio, because you've got to set up all of your ML clusters behind the scenes, etc. It's a more complex environment. There's also a huge amount more functionality. The full ML Studio has a really powerful automated ML functionality, similar to what we looked at with data flows. But it's open, you can see what it does, you can see all the models it creates, you can see the difference between them all, etc. So there's a lot of power in there. There's also, with power comes complexity, and I love the simplicity of ML Studio Classic because it is very, very quick and drag and drop just to create something quite good in only a 3 or 4 minute demo. So I'm going to carry on using ML Studio Classic. Whether it is deprecated, whether it has a shortened lifespan, I do not know. That's one that I will look out for.
Excellent. So what you say, I mean, from my Googling whilst you're presenting, I found the same thing, that I saw no sign that it was deprecated, and I even came across a statement that says there's no way to currently migrate Studio Classic assets to Azure Machine Learning. So I'd be surprised myself if it is deprecated, given that.
Yeah, that's a very good point, actually. That migration is something that I've been discussing with Microsoft about for a while, because when you do have an ML Classic model, it obviously creates the model behind the scenes, and it's a compiled model. You don't have access to the code. You do not have access to be able to take that out into Python or anything else. It is a black box environment. With ML Studio, you get a full capacity to write your own code in there and to really see what's going on. It's a far more powerful environment designed for data scientists. To me, that's the difference. Is ML Studio is designed for data scientists. ML Studio Classic is designed for data people that want to do some machine learning without having to go and do a PhD before they start. But you do not have access to the back-end code. You don't have access to the resulting details of the model. You do have to keep it there. You cannot extract it, but you can consume it in Power BI, Excel, C#, etc.
Okay, perfect. I mean, Venkat's just followed up. He's apparently got an open case with Microsoft, and apparently they advised him to use Azure ML Studio, not Classic. So that'd be interesting to find out, Venkat, more detail to that. So if anyone else has got any more questions, please ask them quickly, because we're now moving on to the last question. And unfortunately, Alex, this one's going to be a bit haphazard, so just bear with me whilst I talk nonsense for a few minutes. So this really relates to when you were talking about using Python and R scripts, and we had a couple of questions about this, and then you did go on to explain. So confirm this if we did understand it correctly, that you do definitely have to use the Power BI personal gateway if you use Python or R scripts. That is definitely the case, is it? If you publish the service?
Yeah, that is absolutely the case. As far as I'm aware, that has not changed. You do have to have the personal gateway, not the enterprise gateway. and that does need to be installed on the machine with the Python libraries or the R libraries.
Okay, cool.
That's one of the reasons why, as a company, we don't tend to do Python embedded into Power BI, because it does impose that limitation on not only performance, throughput, having personal gateways, etc. There's usually a better way of doing it through ML Studio or etc. So yeah, it's there as a facility. If you want it, it's very powerful, but use it with caution, bearing in mind those caveats.
So
Also, if you are going to
okay.
use that, Windows and Python are not the best of friends.
Okay.
With these basic libraries, there's not normally a problem. With some of the more advanced libraries, especially with things like neural networks, a lot of those libraries are very picky on exactly which versions of Python will work in Windows. They're far more flexible and easier to work with in a Linux environment. So you're mixing Windows Power BI Personal Gateway, pointing to a Linux installation of Python. You start to get some potential issues there if everything's on the Windows box because of version compatibility.
Cool. You've kind of preempted the next part to my question, really, because when you were saying that you had to do that, I was thinking, well, surely there is a better way of doing it. You've kind of alluded to the fact that there possibly is. I mean, the two potential options that I wrote down here was, if you really wanted to do this and didn't want to use a personal gateway, would it be feasible perhaps to use Databricks notebook community edition notebook and call that from Power BI, or is that getting a little bit too overcomplicated?
I'm gonna say yes. I've not actually tried plugging ML workloads into a Databricks notebook.
Right.
I know it can be done, but yeah, I'm going to say that's an option, but I wouldn't be able to comment on the details about how effectively that works. Obviously, with that, you've got to have your cluster running to be able to run that workload, which is obviously a cost associated. But yeah.
I mean, bearing in mind the cost, the other thing that I was thinking, I don't know whether this would be feasible either, is to maybe call an Azure function. Is that pie in the sky, or is that a possibility?
Again, not one I've ever tried from Power BI. Yeah, not sure.
Okay.
But I suppose what you could do is, if you've got your own code, deploy it as a web service.
Yeah.
If you've got it as a web service, just pass in a JSON block. The cognitive services that we saw earlier, the resulting model from the ML Studio Classic, it just creates a web service. So if you've got your own code, deploy it as a web service, hook it straight into Power BI. That's probably the easiest way of doing it. You obviously need a bit of coding to build the web service, but yeah.
Yeah, that sounds like
many
a good
ways
idea.
to skin a cat.
Exactly.
And this is evolving all the time.
Yeah.
All the time. Every month these things change.
Yeah, maybe they might actually embed it into the Azure Power BI service. You never know. The libraries. Okay, fantastic. Well, that wraps up the questions. I want to thank you very much for your presentation. I know that everyone really enjoyed it. I appreciate it and look forward to seeing you soon.
Look forward to it. Thank you very much.